for number 69C. Again, we're building up all kinds of equations and reactions here. So I'm going to look what I've got. I've got a reaction involving this acid. I'm going to look at my functional groups. I've got an alcohol here. So when an alcohol is reacting with an acid, we call this a dehydration reaction. And the dehydration reaction is going to give me an alkene, and the water from this and this is going to also be lost, but we're concerned with the organic molecule that we're getting. So that, remember, in organic we don't have to show every single thing, we just are showing that we're what we're going to get. Okay, so I identify first of all what kind of reaction I have, and then I say, okay, dehydration of an alcohol is going to give me an alkene. And the next thing I'm going to do is I'm going to, when I'm dealing with reactions, I'm just going to draw my bonds here. Okay, so I've got two bonds here. I've got this hydrogen right here, and I've got this alcohol right here. Now, if dehydration means to get rid of water, so HOH is water. So if both of these things right here were to go away, that would leave me a carbon that had two bonds. Okay, leave me a carbon that had these two bonds here that I could do something with. Well, we know that we're going to get an alkene, so we've got to form we have to form our double bond somewhere. Okay, so the question is now, is the double bond going to go right here, or is it going to go right here? Which way is it going to go? All right. Now this is a tertiary carbon. It can't lose any hydrogens. It can't get rid of any. This right here has 3 hydrogens. Okay, so if we look at the bonds that are available here, we've got 1, 2, 3 hydrogens here. Okay, so we know we're doing dehydration. So if I were to, take 2 of these, I can, leave this one attached here. So this makes sense to me. I can take these 2 and I can form a double bond between there. Alright, so I can end up turning this into a double bond. But if I take a look at this side, this is a tertiary carbon, and I don't have any hydrogens here that I can get rid of. Okay, so let me repeat what I did again. I said, so far I've got a dehydration reaction because I'm taking an alcohol and I'm adding my my strong acid to it. I know I'm going to get an alkene. So then I went over to my molecule and I looked at where the alcohol was, and I just literally drew those bonds, and I said, okay, so what happens if I pop this open and I were to get rid of water? If I lost hydrogen in a hydroxyl group from this carbon right here, then sure, you had to have 2 bonds, but I've got a double bond with something, so that means that one of these other carbons is going to have to get rid of a hydrogen. So I'm like, okay, could it be this carbon or could it be this carbon? So I look over here at this one, and I see that I can't get rid of any hydrogens here because it's a tertiary carbon. It's attached to 3 other carbons, so there's no hydrogens available. But then I went and I drew out, these bonds right here, and I noticed I've got 1, 2, 3 hydrogens attached. And I'm like, I see now. If I were to end up getting rid of something from here and something from here, that would leave right next door to each other 2 carbons that had a bond open that could form a double bond. Okay, so my double bond is going to go right here between those. So now I'm going to just redraw this to make it a little bit more presentable. So I've got CH3, CH2, CH2. And then I've got my carbon with 2 methyl groups And then I've got this carbon that I'm looking at. It's going to be double bonded to this carbon. And it's going to be able to hang on to this one because, you know, it's got to have 4 bonds. This one is going to be able to hang on to 2 of its carbons, or excuse me, 2 of its hydrogens. So it's going to end up looking like this.